Welcome to Honors Geometry, lesson 4.7, where we talk about isosceles triangles and what the results of having isosceles triangles will do. So first of all, let's laser focus in on isosceles triangles. Isosceles triangles are triangles that have at least two sides that are congruent to each other. Those two sides are called the legs. If there is a non-congruent side, it's called a base. Sometimes there are three legs because that isosceles triangle is equilateral. Now, let's go ahead and drop a perpendicular down. You know what? I'm actually like to use a segment maker to do that. If I drop this perpendicular down and I make it perpendicular, we can do that because of, right, Cindy? The perpendicular postulate. Through a point not on a line, there's exactly one line perpendicular. And we dropped it down so that it was perpendicular. So we have a couple of right angles down here. And you were given that these two sides were congruent. It won't take much work to get this side congruent to itself, right? That side's congruent to itself. Hey, this left triangle is congruent to this right triangle, and I just mean left and right directionally. Those two triangles are congruent using which of the five? You betcha, it is hypotenuse leg. You saw those right angles, you should have been thinking hypotenuse leg. Hypotenuse, hypotenuse, leg, leg. So hypotenuse, leg. Good. So now, using corresponding parts of congruent triangles are congruent, I can make that angle congruent to that angle. And that's going to lead us to the first theorem in section 4.7. That theorem is called the base angle theorem. The base angle theorem says if two sides of one triangle are congruent, then the angles opposite them are congruent. The picture kind of looks like this. If two sides are congruent, then the angles opposite those sides are congruent. Why is it called the base angle theorem? Well, what are these two sides called? Yes, those are called legs. What is this side right here called? It's the base. So this side is the base. These angles down here, those are the base angles. This one right up here, that's called the vertex angle on an isosceles triangle. The vertex angle. Okay? All right, let's go ahead and move on. Okay, remember that little mini proof I showed you how the base angle theorem works? Well, I could have done the same thing with the base angle converse, but I decided not to. The base angle converse says if two angles of a triangle are congruent, then the sides opposite them are congruent. Yes, it's also a theorem, but we're just going to say base angle converse. And it looks something like, ta-da! If you got two angles of a triangle congruent, then the sides opposite them are congruent. So we have these two sides that will end up being congruent just on one triangle. That's pretty cool. All right. Do you remember what a corollary is? Corollary is a theorem that's easily proved from a theorem. And here comes two corollaries, one for the base angle theorem and one for the base angle converse. Are you ready? Yes, I hope you're ready, because here they come. If a triangle is equilateral, then it's equiangular. If a triangle is equiangular, then it's equilateral. All right, we'll go ahead and mark this puppy up. If it's equilateral, well, we can get the base angle theorem working right there. Those two angles are congruent. Let me group these. I need to group these. Okay. Now we're going to rotate that 120 degrees. And we'll make some new base angles. These two sides are congruent, so the angle's opposite. That makes this angle here congruent to that one. Base angle theorem. Hey, look! That equilateral triangle is equiangular. And conversely, if you're given all three angles of a triangle congruent, equiangular, then you can use the base angle converse to get those two sides congruent. And then we'll group those. Give it a nice 120 degree whirl. And now we have these two base angles congruent. That makes these two sides congruent to each other. And voila, as the French would say. There it is. It's also equilateral. All right. How can we use these? I'll show you a couple ways that it might come up in your homework. Okay. Given that triangle SRT, all three sides are 3 meters, what conclusions can you make? You should be able to tell me that angle S is congruent to angle R, which is congruent to angle T, and the measure of angle S equals the measure of angle R equals the measure of angle T, which equals 60. All three of them have to have a measure of 60 because it's equilateral than equiangular. Okay, looking at this, you should be able to use the base angle theorem. Two sides congruent, then the angles opposite those sides are congruent to each other. You should be able to make the following conclusion. Angle F is congruent to angle, what's up, homie? G. That is correct. All right, let's put some math in this. All right, you're given on this triangle that two sides are congruent. That makes these angles opposite them congruent. So an equation is M equals 70. That was pretty easy. Now figure out how big N is. 70 plus 70 is 140. N plus 140 equals 180. N equals 40. Okay. Here you're given two sides congruent. 66 equals 3x. X is obviously 22. And now you get 66 plus 66. That's 132. Subtract that from 180, you get 58. 2y has to equal this 58 degree angle up here. Subtract both sides by 2. Y is 29. And your homework will, for the most part, be that easy. I know you're looking forward to that. And I do believe that's all I have to say for you today. This does conclude Lesson 4.7, Theorems about Isosceles Triangles. Goodbye.